But what precisely is the reason for the high efficiency? A look inside shows the functional principle of a refrigerant dryer and the advantages of a dry point RA Eco in detail. Humid compressed air, shown in blue, enters the heat exchanger at the top at about 35 degrees Celsius. There, it is pre-cooled in a countercurrent process by already dry and cooler air. It then flows through the actual cooler, in which it is continuously cooled down to approximately 3 degrees Celsius. The cold temperature reduces the compressed air's ability to absorb water. The ideally dimensioned demister removes 99% of the water droplets. The condensate then simply flows into the integrated Bacomat condensate drain, and all without the loss of compressed air. The cool, dry compressed air next flows through the upper section, again past the entering air, cooling it as before in a countercurrent process, and is thereby reheated. This further reduces the relative humidity, making the air even drier. The countercurrent principle used within the air-to-air heat exchanger already increases the drying effect and the energy efficiency of the dry point RA Eco. Thanks to the streamlined construction, the compressed air passes almost resistance-free through the vertical heat exchanger without noticeable deflection. This minimizes pressure loss, thus lowering the system's energy consumption. Where else does the dry point RA Eco save energy? Let's follow the refrigerant's path using a frequency-controlled system as an example. The coolant removes heat from the compressed air and gradually evaporates to gas. This gas is sucked into the compressor where it is highly compressed. The higher pressure generates heat. The gas must first be cooled. It thereby condenses back into liquid. Liquid, but still under high pressure, the refrigerant expands in the expansion device. The pressure decreases during this process, also resulting in a sharp decrease of temperature, which provides the heat exchanger with the necessary cooling capacity. The refrigerant evaporates and is drawn in by the compressor again, and the cycle begins once more. In order to save energy when fluctuations in compressed air occur, such as flow volume, temperature, or pressure, the smaller versions of the dry point RA Eco switches the refrigerant compressor on and off to accommodate variations in the drying requirements. After reaching a certain system size, the drying performance is controlled by changing the frequency of the compressor and thus even more finely adjusted to the volume flow. Larger dryers adapt both the speeds of the compressor and the fan to match the volume flow. As the volume flow decreases,